We're now ready for our second speaker. Chang used to be the VP of Engineering here at 2B, but now he's the CEO and co-founder of LanceDB. So we're really privileged that he's doing the talk here tonight. So please welcome him. And his talk is about search, retrieval, training, and analytics with modern AI data lake. Over to you, Chang.
Okay. Thank you, everyone. Always great to be back at the 2B office here, see some familiar faces and more on Zoom. So very grateful. And so I started LanceDB about 3 years ago. Two weeks ago, we were in New Orleans for a team offsite, and we found this regional brand called Lance that makes crackers. And so this has now become our official company Slack. So if you want to ask me some questions, I'm gonna probably feed you some crackers after this. They're actually quite delicious. So you won't regret it. Okay, so here's how today's gonna go. I don't think we have like an hour of material. But what we're gonna do is I'm going to run a live demo, and what we're gonna try to do is ingest, chunk, embed, index, and make it searchable Wikipedia in under an hour or as short as possible. And what I'm going to do is I'm going to kick this off, and I'm going to start a timer. And then while that's going, I'm going to explain what I'm going to be doing, and then I'm going to tell you why you don't actually need a vector database. Okay, so what we're doing here is we're combining Modal and LanceDB Cloud, and we're going to ingest. We are currently ingesting the Wikipedia dataset from Hugging Face, and we're going to use Modal to help generate the embeddings, and then insert that into LanceDB Cloud, and we're going to make it searchable. And this is a data set that's going to give us about 40 million vectors or so, and we're going to see how fast we can do it. So to dive into the code a little bit, and I can share this with you later on, but essentially we start in this Python file called ingest, and most of this is around modal programming, but here you can see the schema that we use for the LanceDB table. So there's a vector, there's an identifier, the index of the chunk within that Wikipedia article, and then the content of the chunk itself, and then of course the URL and title. So one of the interesting things if you're in Python land is that with LanceDB Cloud, you can actually use pedantic models to declare your table schema. So that makes things a lot easier if you're working with agents or RAG applications where your data model might already be in pedantic. And then essentially the code will get distributed over, I think, something like 50 GPUs or something like that. And what it's going to do is iterate over its chunk of the text, and then chunk that up, and then create a bunch of chunks, and then send that to the embedder to be embedded, and then insert it into LanceDB. So the embedding model here that I'm using is Sentence Transformer, and it's a small one. And I'm going to essentially just use that model to call in code on the text, and then convert that back into a NumPy array. And then we're gonna create this dictionary that looks like the data model that I declared, and then insert that. And then we're going to kind of let this run. This is gonna take a little bit of time, right? Remember, it's about 40 million vectors, and we can start talking about some of the things around what actually Lance gives you. And then once it's finished, we can check the timer, and we can see what the result is. Okay. So what is LanceDB? So the LanceDB is we call a database for multimodal AI. And why that is and what that is will become apparent in a second. So my name is Chang. I'm the CEO and co-founder of LanceDB. My co-founder and CTO Lei is back there. And the two of us have spent decades building data tools for machine learning and data science. I was one of the original co-authors of the Pandas library. Lei was a core contributor to HDFS at Cloudera. And among the team at LanceDB, we have PMCs for Apache Arrow, Delta, and Iceberg, and HBase, and others. So I would say some of the most important data infrastructure projects for the past decade. So even if you haven't heard of LanceDB before, turns out you've been trusting this team with your most valuable business data for about a decade. So, and what we're building LanceDB today is for the future of cutting edge AI. And these are a sample of partners that trust Lance and LanceDB with large scale AI data, whether it's multimodal or for vector search, for building really compelling models and also AI applications. So why are we building LanceDB? Why do we need a new database for multimodal AI? The reason is because AI is creating this completely new generational shift for data infrastructure. So if you think about reports from Gartner, we already know that something like 80% of enterprise data today by volume is multimodal. So these are images or videos, think sales calls, Zoom calls, slide decks, all of that. And AI is creating a lot more value out of that multimodal data. It's making it a lot easier to interact with that data, make that data searchable, run analytics on that data, and turn that data into text and structured data. So that's big shift number one. Shift number two is that we're no longer limited by the speed of human and manual input to generate data, right? So new data is being generated by AI at thousands of tokens per second. In practice, we see a lot of fast-growing AI startups that go from 0 to 1 billion embeddings within a year or even more. And moreover, AI data, so embeddings and then text, images, audio, video, all of that multimodal data is actually really hard to deal with for traditional data infrastructure. So what this means is, if you're a traditional, what we call a BI engineer or a data engineer, right? There's a traditional data stack where it's pretty well trodden, pretty mature. So, your data is on S3, it's probably in Parquet, and then you layer Iceberg on top of that, and you can work with that in Spark, and then maybe DBT or something like that to run the models. And maybe you're spending a lot of time in VS Code and Jupyter Notebooks or something like that. But for AI engineers and researchers, this kind of doesn't exist. So this stack becomes really fragmented. From the data layer, you need multiple file formats. Iceberg isn't a great fit. Spark is only good. Spark is not a great fit either for dealing with large-scale multimodal data, and we'll see why in a second. But essentially, for AI engineers, it can feel like you're falling out of a 4-story building, and we need a better stack to support AI engineers as well as kind of the traditional data engineering stack. So the problem starts with the data itself. I think when data is multimodal, it's not just about running structured queries like SQL anymore. A lot of it is about search, and search is everywhere. Whether you're building RAG, whether you're building assistants, if you're working with multimodal data, if you're doing data deduplication, if you're doing data curation for training, all of that requires search. And if you kind of peel the covers, right? What really is search? Search is, indexing plus random access into your data set, right? So you're gonna have an index, you're gonna have a search term, and the index is going to say your search term is best matched to these 10 rows or these 100 rows in your data set, and then you have to go fetch them. Well, it turns out random access in Parquet sucks. It just doesn't really work. And you have to read out the entire page or the row group to fetch single rows. And so when the data is tabular, when it's just floating point numbers, this is okay. It's not great, but it's maybe okay. But the problem is AI data is much bigger, right? And embedding is 3,072 floating point numbers. Images, videos are even larger. So if you have to fetch the entire page, random access just doesn't work. And so this was the idea behind what we built into Lance formats, an open source columnar format, Lance format V1, which was changing the data layout so that you can do single row fetches in sublinear time. And so that was a great step forward from Parquet for AI data. Now, the second problem we ran into, which motivated Lance format V2, is that multimodal data is wide, right? We see that images and videos are much, much bigger. So if you're storing these wide columns together with other metadata that are numerical data, categorical data, or small strings, what is the problem? Well, the problem is that, look, between your different columns, there could be up to 9 orders of magnitude difference, right? In terms of gigabytes per row to just a few bytes per row. And the problem is with Parquet in row groups, it forces you into really bad trade-offs. So this is one extreme with one option with Parquet, is that you have these really giant row groups. So if you kind of use the default number of rows per row group, these make it really memory intensive to write. And then there's very little parallelism that you can have on reads. So that means your row group sizes are optimized for essentially the small columns. And then that means you're carrying a ton more data within each row group for the wide columns. Now, on the other end, you can optimize for kind of right size to get rid of the out of memories. You can have very small row groups, right? Then what happens is then your narrow columns get put in these incomplete run pages, and they're very tiny and very suboptimal for reads. So this is really bad for scanning if you're doing analytical queries on the metadata. And so this is the reason why we designed Lance v2, which is essentially a two-dimensional data structure. And it turns out there's another problem that you have, and it's not just at the Parquet level, but at the iceberg level, is that with multimodal data, you never really want to copy data that you don't have to. But if a single row is a couple of gigabytes, you really don't want to copy data. And so if we take a look at how kind of a data set evolves over time, thinking about data science, is that you might start out with a core data set that's the raw assets, maybe it's text, maybe it's image, and then you have a bunch of features. Well, over time, you're going to grow this table both horizontally and vertically, right? So every day, maybe new observations come in, you're going to add new rows, but then over time, your data science team or your research team is going to do a lot of model experimentation, and it's going to add new features. So it's going to grow. Grow horizontally here as well. The problem with something like Iceberg is that when you add new columns, it's hard to do backfills. It fills in the existing rows with empty or nulls, and so you end up with these artifacts. I would call it geological seismic shifts in the data. So as you can fill the new rows when you add columns, but if you want to do a backfill, then you have to rewrite the data. Partly this is because with Parquet Iceberg, this is a I would call a one-dimensional table layout where the entire row has to live within the same file. So Lance v2 essentially creates this two-dimensional layout for your data. It's still columnar, but different columns for different versions can live in different files. So the green is essentially writing in new columns. When you write in new columns, they just live in additional files. So backfill becomes very easy. You don't have to copy the existing data. And of course, you can write new fragments as you write new rows. And so that you can grow this table vertically as well. So turns out this is a much, much better match for multimodal data, multimodal AI data that you need for model experimentation or building applications on top of. Okay. Let me just check in on, oh, actually it looks like it finished. I'm gonna stop the clock here. I think it's probably gonna take a few, so it looks like, yeah, it's gonna take a few minutes to finish indexing. This is just the ingestion part. So we're gonna come back to this in just a minute, but we can keep an eye on this now. So in a nutshell, what Lance format gives you is this ability to have fast scans like Parquet does, but then to give you random access, which you need for a lot of things, search for one. Number two is for shuffling if you're doing training, and then if you're doing filtering and the things like that, you need fast random access and the ability to manage large blobs together with small data. And Lance is the only format that gives you kind of all three. So I call this kind of the cap theorem for AI data. So without Lance format today, we see some combinations of, say, Parquet and Iceberg, plus maybe storing the raw images and videos in web dataset. And the idea is you can put all of that into Lance directly on S3. Especially, have you guys heard of web dataset? Have you worked with web dataset before? So it's basically a bunch of tarballs that packages up your images and metadata. So if you want to create a new feature, you have to download maybe terabytes or petabytes of tarballs, unzip them all, compute the feature, add it in, tar them back up, and then upload it back. So that is really expensive and it's really slow. Whereas with Lance, you store the data on S3, you just write a new column with that feature, and then you're done. Okay, so what Lance gives you is this this one place, one table where you can put all of your AI data, whether it's the metadata, the text description, the image, the image frames, the video itself, audio track, and of course the embeddings, right? So, and more than that, it's also a single source of truth for all of your AI workloads. So you can run SQL queries on this columnar data set. You can plug this into PyTorch data loader for training. And of course, you can create a vector index on the embedding columns to search similar videos. One of the things that's interesting about the indices in Lance is that it's disk-based and not in memory. So the object store gives you compute storage separation, and the disk-based indices gives you a much better memory efficiency as you're doing search without sacrificing performance. Okay, so if you're putting all this together, right, what we actually have is a full database for multimodal AI. Your data is stored in a single place in one table. It's open source in object store. And within LanceDB, you have ways to run your data pre-processing to add columns and to do schema evolution, to do vector search, full text search, hybrid search, run SQL queries, and then train your model on top of this, on top of the format as well. And so LanceDB, we've been around for about 3 years. In production, we see massive scale for training and search in these AI workloads. at 1/10 the cost of the other competitors out there for each of these options. So the largest training data set we've seen in production is about 20 petabytes. I think the largest table we've seen indexed is 10 billion vectors, more than 10 billion vectors. And I don't think we've seen anybody else able to do top our throughput on a single table for vector search. So all of that is kind of, it comes from this fundamental shift in architecture from the data layer up, and that gives us this way to kind of bust open the scale versus cost ratio. Okay, so so this is the reason why you don't need a vector database, because all of your AI data is in one place. It's automatically searchable, it's trainable, it's transformable, it's analyzable, right? You don't need to take a part of your data, just the vector, and then maybe copy some of the metadata to this other place and maintain a sync between your source of truth and probably in your object store and some other system that's serving as a vector database. So what you really need is a database for all of your AI data, right? So you can let's actually check in on our example. So so here, this is basically 41 million. So this is a Vercel app I created in front of the data set. And so if you search for that, it finds January 1943, died Nikola Tesla. I don't know if somebody wants to give me a question, we can type it in and see if we get a good search. Anyone want to ask a question to Wikipedia? Got a hand over there. No? What is the average what speed? Was it flying speed of a laden swallow? I hope it comes back with, I don't know, European? Okay. Yeah, that's a pretty good answer. Cool. And so, I think what we can look at is when we go back to my project in LanceDB Cloud here, essentially what's happening is, so this table is backed by this data set, Wikipedia. You can see the same schema. And this is all. Am I standing still too long? Okay, all right. And so this is completely serverless, so you don't have to manage any infrastructure. And the reason why I even dare to run this was I actually don't need to run anything on my laptop. There's no server that I need to maintain. So Modo is basically a way for you to get GPU serverlessly. LanceDB is completely serverless search and retrieval for your AI data. And yeah, so you see in about 14 minutes and it finished ingesting, and we can run queries on this pretty quickly. And so we did all of that within, I guess I started at 7:05 probably, so under half an hour, which is pretty good. So if you guys think you can do better, sign up for LanceDB Cloud, and we can have a bake-off. And so, of course, the Lance format is open source, and there's an open source version of LanceDB that's like an embedded library. So think SQLite for vector search, and we'd love it if you would join our Discord community. For chat or support for like LanceDB Cloud. Okay, so let me just stop here. I'm going to open it up for questions.
Thank you for the presentation. So a couple of questions related to the creation of embeddings. Can you choose what type of embeddings you create using what models?
Yeah.
And how effective the out of the box is for images? I saw text, audio, video, but no explicit mention of image.
Yeah. So for images, there's two ways to add embeddings to LanceDB. One is you can compute anything that you want, and you can just insert the embeddings yourself. Number two is LanceDB has what we call an embedding registry. I think by default, there's like maybe 20 or so different embedding models out there. You can pick one, or you can implement your own, and that makes it a lot easier. You can just insert the raw data, and the embeddings get computed automatically. For images, of course, there are lots of different options. The most popular options we see are some variant of clip, siglip. There's a number of newer late interaction approaches. So Copoly is probably the most interesting one that does multi-vector embeddings for an image, and typically it performs pretty well against like a clip variant. And so those are the ones that we see a lot. And then certainly like image embeddings, there's classical image embeddings from like ResNet and those types of embedding models. Yeah.
Is there any reason why this couldn't just be Parquet 3.0, the data format?
I mean, we tried to make it work on Parquet for a long time, and so we didn't start out saying let's create a new format. Parquet is, I think, 10 years old. I think at this point, and these are very, very fundamental changes to the architecture of Parquet, and there's a lot of inertia around moving Parquet forward. So even I think small changes are difficult to affect, and the fundamental architecture changes are nearly impossible.
So conceivably, it could be if there was enough momentum behind it.
I mean, if you rewrote Parquet to be Lance, then yes, right? It's basically just calling Lance Parquet. But yeah.
Anyone else got a question?
First question, I missed the setup for the demo. What exactly you're scraping? It looks pretty impressive.
Yeah, so this basically it's this Hugging Face data set. So
which is, I assume, what years or like what's the scope of this?
I'm sorry?
Do you broadly know what the scope of this data set is? Like what?
Yeah, so this is the English split for this. And it comes out like the way we chunk it comes out to be about 40 million embeddings or so.
Awesome. Yeah, that's really impressive. Second question. So I guess one of the selling points of Lance is like indices are on disk, so you could scale up like how much you could use. So how does that compare to like other approaches that competitor vector DB solutions do?
Yeah, absolutely. So I can show you our kind of architecture here. So basically the object storage is where your data lives. And then with LanceDB, we have a cache ring and then a query fleet that can auto scale up and down. So the interesting thing about new generation of vector workloads for AI is that you tend to have a huge number of vectors, but the query load and compute demand is much smaller and tends to be spiky, right? This is contrasted with previous generation of vector workloads that are like search engines, so like Elasticsearch or OpenSearch, where vector volume is smaller, compute is much larger, and so the other vector databases out there are architected in a way that doesn't give you compute storage separation. So if you need to store 100 million embeddings, you have to have enough compute nodes for that storage. And so you're probably wasting most of that compute in that cluster. And so and it's also very difficult to add and scale. So that's the other new phenomenon that we see with AI is that new data can come in very quickly. And so when you have a cluster that doesn't give you compute storage separation, I think like take Azure AI Search, for example. Like we hear from customers that are like, yeah, we were on Azure AI Search, and every time we scaled up, it required us to run a whole data migration where we would create this new cluster, migrate the data over to the bigger cluster, and then make sure that was working okay, and then shut off cut over traffic and shut off the old cluster. And like, if you're a small team building a new AI app, that is not where you want to be spending your time. And so LanceDB is designed for this new generation of AI workloads on vectors. So you have complete compute storage separation. The query fleets are stateless. So auto-scaling up and down is very simple and very quick, very fast. And you don't have to do like resharding or anything like that as your traffic increases.
Great. Anyone else got questions?
I'll say that thank you for being my plant. That was a great question.
I saw the podcast you had with the folks with Practical AI.
Oh yeah.
Yeah. So that's when I first got exposure to LanceDB. That was really cool and fascinating. So I think it stands out compared to some of the other ones.
Thank you.
Yeah.
Great.
There.
I was wondering if batch size is something that can be for reads, can be configured. Is that something that can be defined? And then is that something that does LanceDB provide functionality to like automatically decide on a batch size, like depending on ingested workloads?
It depends on what workloads you're talking about. So when you say batch size, like, are you thinking just like data ingestion, or are you thinking like search?
I was thinking mainly for like data ingestion. Yeah.
Oh, data ingestion. Yeah, I mean, typically the batch sizes are set for the like most there's I forgot what the default is, but like it's set so that most reasonable like image sizes would fit on like modern nodes. But yeah, they can definitely be tuned. Yeah.
Great. Any other questions?
Awesome.
Great. Well, thanks everyone for coming to. Oh, sorry.
No, that's fine. I see like LanceDB feels like it is like cloud agnostic, so to say. But are there any quirks between like Azure, AWS, or on-prem where LanceDB works a little better with one as opposed to others?
Yeah. So I mean, it's the same architecture. So LanceDB Cloud is the serverless offering that we have. And then for larger organizations and teams that need everything to be on-prem, that's basically LanceDB Enterprise, and we can deploy on all three cloud vendors, and we can connect to any S3 compatible API for storage backend. So if you use, I don't know, like MinIO or Tigris Data or any of these kind of like, or like probably R2 now as well. So you have lots of different options there.
Thank you. So what's the interoperability story with Iceberg? For example, if I already have an Iceberg Lakehouse, now I want to also adopt Lance. Should that be sort of two separate systems, or they're going to be one solution? I can see the catalog layer where I sort of abstract away whether it's Lance or Iceberg. Does not matter.
Yeah, exactly. So I think it's going to so right now we see Lance as a great complement for Iceberg, in that like our our goal is not to replace Iceberg in like tabular data workloads, but it is to supplement Iceberg for AI workloads. So the way that it's architected is you can federate at the catalog level, right? And then there's also APIs that we're adding to make it easier to sync your data back into Iceberg if you want to.
Great. Any other questions before I miss anyone's hands?
Yeah. Any questions on Zoom?
On Zoom, yeah.
I have one. Hello. Is there an easy migration path from Parquet to Lance, kind of similar to what you were just talking about with Iceberg? Or is it really
Yeah.
just high IO read write?
Absolutely. So yeah, exactly. So the migration story from Parquet or really any data format to Lance is like it's 2 lines of code. You read the old format into Arrow, and then you write it into Lance. That's it. So you can do that if your data set is small. You can do that in like pandas and polars and call it a day. If your data sets are larger, we've had folks migrate the data over using Spark or Array.
Great. Anyone else online or in person got a question? Great. Great. Well, thank you, Chang, for the great talk.
All right. Thanks so much, everyone.
Thank you, Howie, for your talk as well. Thank you, everyone, for attending. And if anyone wants to do a talk at our meetups or host us, please get in touch with me. Thank you all. Have a nice evening, and feel free to network till we're asked to leave. And when we're asked to leave, we can always go to a bar near.